Today we're going to be learning about special factoring types. So the first one we're going to look at is called a difference of squares. So our first example says x squared minus 25. So first thing we have to do is turn this into a trinomial. So if we know the x squared term, but there is no middle term, there's no x term, there's no linear term. So I'm going to put plus 0x in there, because if there isn't one, that means I have 0 times x. And then minus 25. Just like we normally do, we're going to multiply the a times c. Since a is 1 in this case, 1 times negative 25 still gives me negative 25. I'm going to go ahead and think about the factors of negative 25, and I'm looking for one that will add up to 0. So if I list those out, negative 1 and 25, 25 and negative 1, negative 5 and 5. So those are all my factors of negative 25, but the only one that adds up to 0 is negative 5, positive 5. So I'm going to rewrite my expression as x squared minus 5x plus 5x minus 25. And now we're going to factor by grouping. So if I group these first two together, they have a GCF of x. X times x would make x squared, and x times negative 5 would make the negative 5x. The second set, I'm going to factor out a positive 5. So 5 times x would make 5x, and 5 times negative 5 would make negative 25. Notice that our factor matches, so I'm going to factor out that x minus 5. And if I factor that out from each, I have leftover x and leftover positive 5. That would be my factored form of that trinomial. Notice, guys, that one has a positive 5 and one has a negative 5. So if you do remember that pattern for difference of squares, that pattern will always stay true. We'll have one positive and one negative, and the numbers will match. Okay, taking a look at the next example, we have 9y squared. Our middle term is missing, so I'm going to fill in plus 0y minus 64. If we multiply a times c, we would be multiplying 9, that's the lead coefficient, by negative 64, that's the c, that's the constant term. So if I do that over here on my calculator, because those numbers are kind of large, 9 times negative 64, that gives me negative 576. Now, if I were to list out all of the factors of negative 576, I could be here for a while. But remember what we said in that last slide. We're looking for the same number. One has to be positive and one has to be negative. So what I'm going to do, guys, is I'm going to take the square root of that number, 576. So that tells me if I multiply 24 times negative 24, that is going to give me that negative 576, and they also add up to 0. So that's the pair that I want. I'm going to rewrite my trinomial, 9y squared minus 24y plus 24y minus 64. It doesn't really matter the order in which you put that positive and the negative. I actually just realized that I had the positive written first and the negative written second, and then I just reversed them. It doesn't matter. You could put the positive 24y and then the negative 24y. Just be careful of your signs. All right, I'm going to pair the first two up, and we could factor out a 3y. So 3y times 3y would give me 9y squared, and 3y times negative 8 would give me negative 24y. The second pair, taking a look at that, 8 will divide into both of those. So I'm going to factor out an 8. 8 times 3y will give me 24y. And 8 times negative 8 will give me negative 64. Again, we have that matching binomial there, so I'm going to factor that out, 3y minus 8. If I factor those out, I have left over 3y from the first factor and positive 8 from the second. So there is my factored form. Okay, the other type of special factoring that we're going to look at today is called perfect square trinomials. So notice we have a trinomial already. So at this point, I'm just going to multiply a times c. If I multiply a times c, the lead coefficient is 4 times the constant is 9. 4 times 9 gives me 36. I'm going to list out those factors of 36. Those are 1 and 36, 2 and 18, 3 and 12, 4 and 9, and then 6 and 6. We're looking for the pair of factors that will add up to 12. So looking at those, the 6 plus 6 will make the 12. So I'm going to rewrite my trinomial. 4x squared plus 6x plus 6x plus 9. Grouping the first two together, I can factor out a common factor of 2x. 2x times 2x will make 4x squared, and 2x times 3 will make the 6x. The second grouping, I notice that 3 will divide into both of those. 3 times 2x gives me 6x, and 3 times 3 gives me the 9. Again, we have that matching binomial, so I'm going to factor that out. 2x plus 3. If I factor those 2x plus 3's out, I have left over a 2x from the first set and a positive 3 from the second. Notice, guys, that we have the same binomial here written twice. So I could write that with an exponent. So 2x plus 3 quantity squared. That is what makes this a special type of factoring, perfect square trinomial. Okay, the last example for our notes today that we're going to go through together is 9x squared minus 24x plus 16. It is another perfect square trinomial. So we already have 3 terms. It's already a trinomial. So I'm going to multiply a times c. If we multiply a times c, the lead coefficient is 9 times the constant is 16. So if I multiply those, 9 times 16, that gives me 144. All right, so I'm listing out the factors of 144. We've got 1 and 144, 2 and 72, 3 and, let me divide those two. 144 divided by 3, 48, 4 and 36. 5 does not go in. Does 6 divide evenly? I better check that out. Yes, it does. 6 times 24. 7 does not. I better check 8. 8 times 18. 9 times 16. 10 does not go in, 11 does not go in, but 12 does. Whew, that's a long list of factors, guys. I am looking for a negative 24 when I add those together. If I keep all of these positive, there's no way they're going to add up to a negative 24. But if I make one positive and make one negative, that's going to give me a negative 144 when I multiply. And I need a positive 144 when I multiply. So the only way that they could possibly multiply to give me a positive outcome and add to give me a negative is if both factors were negative. Because a negative times a negative will make a positive when I multiply. But when I add two negatives, I still get a negative. So I'm going to go back through and make all of these negative. Take a second, guys, to really double check your signs when you're doing these and making sure that when you multiply, you get the correct sign, and when you add, you get the correct sign. Okay, so now I'm looking for the sum of negative 24. And right here it is. Negative 12 plus negative 12 will give me negative 24, but negative 12 times negative 12 will give me the positive 144. Okay, so let's rewrite that trinomial. 9x squared minus 12x minus 12x plus 16. Grouping them together, 3x is the GCF in that first pair. 3x times 3x will give me 9x squared, and 3x minus 4 will give me that negative 12x. The second group, notice there's a minus 12x and then a plus 16. So I'm going to need to factor out a negative 4. Negative 4 times 3x will give me negative 12x, and negative 4 times negative 4 will give me positive 16. Our binomials match. That's what we're looking for. So 3x minus 4 is the common binomial, and the leftovers in the first set is 3x, and the leftovers in the second set is negative 4. I did get the same binomial twice, so I'm going to represent that with an exponent. I have the quantity of 3x minus 4 squared. And so that is our final answer. Okay, guys, we're at the you try slide. So take a look at those 4 questions. The first 2 are the special type of differences of squares, and the second 2 are perfect square trinomials. So factor those out and then unpause the video to get those answers. Okay, here are the results from the you try. We have 5d plus 2 times 5d minus 2 for number 1. Number 2, r plus 4 times r minus 4. Number 3, the quantity t minus 3 squared. And number 4, the quantity 2y plus 5 squared. Okay, guys, that concludes notes for today.